So far, we've spent a lot of time talking about how to take samples in a random way to make it fair, and like surveys and stuff like that. We haven't really talked about this concept of an experiment versus observational study a ton. We did like the briefest introduction. And when we do like a sample and then give them a survey, that's an observational study. Whereas an experiment is something where we assign treatments, and we're going to use the word treatments a lot this week. Okay? We assign treatments to 2 different comparison groups or 3 different comparison groups or whatever. We create great groups for comparison in an attempt to see, do the treatments cause any differences? And the big idea, the reason we love experiments is an experiment allows us to conclude cause and effect. Can't conclude cause and effect from an observational study. We can conclude cause and effect from a well-run, a well-designed experiment. So, we got to go over some quick vocabulary. We have experimental units. The experimental units in a study are whatever receive the treatments. Okay? So, remember the first experiment you guys actually came into contact with in this class was the Nate and AJ versus AJ and Nate versus the boys. That was an experiment where you were assigned treatments. Y'all were the experimental units in that case because you were the ones that received the differences amongst the different file names. Does that make sense? Okay. The treatments are the intentional manipulations. In other words, they are what is assigned. And sometimes, like for medication trials, sometimes the treatments are like a placebo, a low dose, a medium dose, and a high dose. And that would be 4 different treatments. Does that make sense? So sometimes the treatment doesn't just describe the what, sometimes it describes the how much. Does that make sense? Okay? The explanatory variable is, I like to think of it as the umbrella over the treatments. So in that one I just described, the placebo, blah, 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 and the different dosages, the umbrella would be dosage of drug, right? That would be the umbrella that kind of covers everything. That's what we're using to explain our response variable, which is the variable we are looking for a change. Okay. Confounding. Confounding happens. It's basically what it is when an outside variable makes it look like the treatments worked. Instead of the explanatory variable. So, an example that we've already talked about this year, ice cream sales and shark attacks. Okay? If we looked at that with a, gullible eye, we would say, oh, ice cream causes shark attacks, right? But what's the confounding variable? The weather, right? When it's warm out, more people are swimming. When it's warm out, more people are eating ice cream. So notice that, it's that confounding variable weather is tied to both the explanatory and the response variable. Is everybody with me so far? All right. So I'll let you guys look at this for a little bit. What do you think, first and foremost, experiment or observational study? Why?
Because they aren't really doing anything out of their way that isn't different to their normal routine.
So I'm going to say this is an observational study. And what's the explanatory variable here?
Getting grades. Right.
That's the response variable, is academic achievement, okay? The explanatory variable is whether or not people eat dinner with their families regularly. Are you guys with me here? And so if I really wanted to do this, I would say the dinner with family or not, I guess, was not assigned. Because that's what the treatments would be. Just adding a little bit more context here. And since we just said it, the explanatory variable is dinner with your family or not. And the response variable is academic achievement. So, if this was not an experiment, can we conclude cause and effect? All right. Now, we haven't really talked about this yet. But in order to conclude cause and effect, you need randomly assigned treatments. We'll talk about that a whole lot more on the next page. So what's a confounding variable in this?
Maybe like family expectations or something.
Maybe family expectations. Guys, I want you to think about the last time you had a conversation with your family. What's one of the first things your parents ask you?
Sports.
Sports?
Grades. Yeah.
Like, I can tell you the very first thing Mama Meister used to say when we got home. How was school? How often do you hear the phrase, how was school? Right? So if you're having those conversations with your family more frequently, are you not going to be like more, aren't you being more held more accountable than somebody who's not having those conversations to your own academic performance? Do you guys see what I'm saying here? So the confounding variable might be the conversation with parents, right? People who have dinner. So we might say students who eat with their family more frequently So they probably have more conversations about school. And in the end, if I really want to talk about confounding, the basic idea is now, like at the end of this, are you guys with me that we don't know, was it the conversations or was it the eating dinner that caused that increase in achievement? We don't know. Sure. All right. Notice as we talked about this, I've taken this idea of having these conversations and we've tied it in two places. One, I tied it to eating dinner more frequently, right? And then I tied it to increased achievement, okay? So whenever you're trying to talk about confounding, which is relatively likely that you're going to have to do, okay? You need to tie it to both the explanatory and response variable. All right, now, you guys remember the tea lady? Where she had 8 cups of tea and some of them had milk poured first, some of them had tea poured first. Was that an experiment? Was it? Yeah. Because what were the treatments? It was the different orders of which the stuff went into the teacup. Yeah? Okay. And when I asked you guys to help me understand this, what are some things you would want to make sure? You guys said, hey, we need to make sure all the cups are the same. And that the temperature was the same. And that the proportion of milk and tea was the same. You guys remember all of these things? Okay. So these next 3 things, we're going to talk about, these are, every good experiment has these 3 things going on in it. Is this okay? All right. So the first one is control. This means, make the treatment groups as similar as possible. In other words, for the tea, just like to connect it to that tea lady example, same cups, temperature, etc. Now, another way to think about this is so essentially that control means control for lurking variables. Remove as many lurking variables as you can. Okay? So we didn't want her to be able to tell the difference based on some other characteristic other than what was poured first versus second. Make them as similar as possible. Okay. Now, the next thing we need to do, and this is huge, is in an experiment, can you control for every lurking variable? You can probably come close to controlling for every lurking variable that you know about. But are you with me that there's probably the whole point of using experiments instead of our own intuition about what we know is that there's a lot more things that we don't know than things that we do. Okay, so this next part is, this random part is assign treatments randomly. And what that does, the goal of doing that is you want all your treatment groups to be as similar as possible. Is everybody with me? In fact, what you want to do is try to make the only difference between your treatment groups the treatments themselves. Okay? And you control for the things you do know about. You randomly assign for the things that you don't. Is this okay? All right. So let's say I've controlled for everything with these teacups, but there is like this one other thing that I didn't think of, and we'll pretend it's the temperature. Okay, but it's like we would have controlled for temperature, but let's pretend it's that temperature. And then all of the sudden, and you guys said this, when we serve her the tea, you guys said, well, we have to do them in random order. Do you guys remember saying this? Why?
So you can't find a pattern.
But what would be wrong with there being a pattern? If she can taste the difference, she'll say it, right? Well, maybe then that pattern is the problem. Or maybe if you did all the tea first, then all the milk first, second. Oh, they're all of a sudden colder for the second half. All the milk first are at a different temperature. Okay? And it's not intentional that you do that. So random assignment controls for all of those things. Okay? And all right, last thing. This again happened with the tea lady. If she got 3 out of 3 correct, would that have convinced you? 4 out of 4? Would 4 out of 4 convince you? 5 out of 5? 6 out of 6? 7 out of 7? Some of you weren't convinced at 8 out of 8. Some people wanted more trials. You with me? So what replication is, this last thing, is that the groups are large enough that you'd get similar results. If the experiment was replicated. How we feeling, okay? All right. All right. So experiments have, you're gonna hear us talk about these like treatment groups, lots and lots and lots. Okay? All right. So every single experiment has at least 2 treatment groups. One of them might be called a control group. Okay? What's a control group?
Remains the same on the basis of the experiment.
So a group that doesn't get a treatment, and oftentimes the control group is used to create a baseline. So thinking about Nate versus AJ, then AJ versus Nate, and then the boys. You guys were the group that got the boys. You guys were a control group, just to see what % of people would get it right, regardless of the manipulation. Does that make sense? All right. What's a placebo effect? Have you guys heard the word placebo before? Most of the time, kids have heard it, like in the science class. Okay. What is a placebo?
It's a false interpretation of something happening, even though it's not.
Kinda.
I was gonna say it's like you tell your experimental group. I don't know.
Experimental unit. Your subjects. We use the word subjects if the experimental units are people. So.
That you are giving them or changing something about like what you're doing. So like if like saying you're gonna get this medication, but really it's just like a sugar pill, but them not thinking that they're gonna have some type of effect from that pill, like kind of makes it, I don't know, makes them feel better, or I don't, they kind of.
Okay, you're getting there. All right, so here's the deal. The act of receiving a treatment of any kind, knowing you are in an experiment, does cause a response, and we call that response the placebo effect. Okay, no matter what the treatment is, you receive or you respond in a way. Okay, so the placebo effect is a response to any treatment regardless of what it is. So now, what's the problem with that? Is, well, let's say I'm doing a drug trial and I know that everybody's going to respond. Now if the group that gets the drug responds, that doesn't mean the drug works. Because what we would want to look for is the group that gets a drug trial, right? Gets the actual experimental drug, responds more than the group that got the placebo. Because if everybody's going to respond at least a little bit, does this kind of make sense? Because you want to rule out the placebo effect. So those placebo itself is usually a fake treatment of some kind, oftentimes a sugar pill, okay? But the whole idea is you want the placebo, like the intention is to create that control group. A placebo group is kind of like a control group, kind of. It's a type of control group. Does this kind of make sense? Okay, so a placebo could be like a fake treatment to create a baseline. All right. Have you guys heard of blinding in an experiment before? Like a single blind or a double blind experiment?
Yes.
Yes? No? Okay. Basic idea behind blinding. In a blinded experiment, so like if you think about the experiment has the people conducting the experiment and then the people receiving the treatments, the subjects, okay? And so when we blind an experiment, at least one side, for a single blind, one side doesn't know the treatment. The Nate and AJ stuff I put you guys through, in some respects, was single-blinded because I knew the treatments, and you guys didn't even know you were in an experiment. Is this okay? Cool? All right. It's one side doesn't know the treatment. Sometimes it's the other way around. The person administering, like let's say I wanted to decide, does flashcards versus online practice help kids learn math facts better? Okay? And then what I did is I let you guys flip a coin and then I left the room, so I didn't know which treatment each of you got, but you knew which treatment you got. Do you see what I'm saying? That could also be single-blinded because I'm the one conducting it. I'm the one doing the analysis, but I'm not the one assigning the treatments. But you guys would each know which treatment you got, right? Does that make sense? All right. And then double-blind is both sides don't know the treatments. Thanks, Trey. All right. In this study, I'll let you guys read this real quick, and then we're going to describe one, how we would control for lurking variables, then how would we randomly assign, then describe the replication, and then what would we measure. So, in a study such as this one, what are some of the lurking variables?
The foods could have both low fat and low carb. Like
Say that again?
Like if you get a low fat, it could be low carb, like as well.
Okay, so what else? That's good. Hey guys, I can eat a low-fat diet and it'd be 3,000 calories a day. Because you know what I would eat? Lots of candy. It would be the best. Because I have a wicked sweet tooth. Right? But there's no fat in candy, depending on the type of candy, right? Like Skittles and stuff like that are usually pretty low fat. But I promise you, if you eat Skittles for lunch, breakfast, and lunch every day, you're going to gain some weight and probably some cavities. Right? Are you guys with me? So do you think the total calories within the diet plan would probably be a lurking variable? Certainly some low-fat foods are also low-calorie because fattening foods have fat per milligram or whatever has more calories than protein, etc. Right? Do you guys see what I'm saying here? There's a lot to kind of like parse through here. So the amount of exercise that people do? For sure. For sure. Okay, so what if I said have a prescribed list of foods for each diet? With appropriate caloric intake per subject. So in other words, when I say appropriate in general, if you weigh more, your body needs more calories than if you weigh less. Okay. All right. Limit subjects' exercise. Which for a year-long study might be a challenge to do.
Just slap a Apple Watch on them and just rigorously track them and yell at them.
Certainly in the world of metrics now, it is a little bit easier with wearable technology, for sure. Okay, now, is this feeling good so far? Do you feel like we've controlled for a lot of lurking variables? Have we controlled for all of them? No, so the next thing we're going to do is have our random assignment. And your next, guys, I think I have a quiz for you on a week from tomorrow is your next quiz. Then your next test is a week from Thursday. I guarantee on that quiz you will be asked to describe random assignment. Is this okay? All right. So I have 90 subjects. How many treatment groups am I putting them into? 3. All right. So do we want to have the same number in each group? Do we have to have the same number in each group? No. But in this particular case, I think it's relatively easy to do. Okay, so here's what we're going to do. Give each subject a number between 1 and 90. What do you think I'm going to write next? Why would we give the people a number?
First 30 are like a control group, and then like the middle 30.
But why do I need to give them a number to do that?
So that it's random.
Use a random number generator, because that's how I get it to be random, is I have to use a RNG, yeah? To get 30 unique numbers. These subjects will get a brochure about healthy eating. Feeling good so far? So we have our healthy eating group. Are we done assigning our treatments? Okay. So then use the RNG to get 30 new and unique numbers. Who do you want these ones to be?
Low carb.
Have these subjects follow a low carb diet. Then what? Do we need 30 more? There's only 30 left, yeah? Is this okay? And then I'm going to talk about replication here just to reinforce it, but there's not really much, like since the parameters were set. So for replication, our groups are large enough that chance doesn't describe the differences. In other words, they could not occur by chance. All right, so the last thing we're going to do is examine the change in weight, since this is all about weight loss for each treatment group. What do you guys think? Is this okay? And this would be what I expect in terms of designing a experiment in this matter.